Good morning, everyone. Let us start this session. So, in this session, we are going to study the law of polygon of forces. So, we will verify this law of polygon of forces from the experiment. Okay. So, this is your experimental setup. So, this is the board which is mounted on the wall. Then these are the pulleys. So, this pulleys, we can fix this pulley with this bolt. And during the experiment, even we can change the position of this pulley, okay, in this direction, in the vertical direction. So we have connected one weight. So this is the string which is passing over this pulley, and here we have connected one weight. Okay. Similarly, from this pulley, so this is the second weight. This is the third weight. Then this is the fourth weight. And this is the fifth weight. Okay, so there are total 5 weights which are hanging to the cables or the string, and the string is passing over the pulley. So each weight will create the tension force in the string. Okay, so this tension force we will assume as a F1. So this is the F1, this is the F2, this is F3, this is F4, and this is the F1. Okay, so all the 5 forces, they are passing through this common point. So this is called as a point of concurrency. Okay, so it becomes the concurrent force system. Now for this force system, we have to find out the resultant from the experiment from this diagram. Okay, that is from polygon diagram, and by using the summation fx and summation f1. So here our experiment, and we have to find out our theoretical. Okay, so our experiment, it is based on the force polygon, and this R theoretical, it is based on the summation fx and summation f. Okay, so during the experiment, this is your physical setup. The weights are hanging from the cables. Okay, this is the point of concurrency. So as the given system is in static condition, okay, so resultant must be 0. This is the theoretical value. But due to some friction, so if there is a friction between this string and this pulley, then there will be some resultant, and that resultant we can find out by using this polygon. Okay, so how to find out that resultant by using the polygon method? So here your first step will be, we have to draw this force diagram on the paper. Okay, so this is your point of concurrency. This is your F1. This is the F2. This is F3. F4 is exactly vertical, and this is the F5. Okay. Then consider the reference axis. This is X and the Y. Now measure this angle by using the protractor. Okay. Because this line you can find out from the experiment. Okay. So basically we connect one paper on this board. Okay. Then we mark the points. Okay. So we use mirror to mark these points. So basically you will get this direction from the experiment. So we have to measure this angle by using the protractor. So let us take this angle as a 35 degree. Then this angle, it is 30 degree. This angle is 40 degree. And this is also 40 degree. Okay. Then this magnitude F1, suppose we have taken this 100 gram. This is also 100 gram. Then F3 is 125 gram. F5 is 125 gram. Okay. And the F4, this value is 200 gram. Okay. So these values you will get from the experiment. You have to measure how much weight we are adding in this pan. So this is called as a space diagram. Okay. From this space diagram, we have to draw the polygon diagram. So what is the law of Polygon of Forces is, for the concurrent force system, if we represent the force as a sides of the polygon taken into order, then the closing side of that polygon, it will represent the resultant. Okay. So we have to first convert these forces which are in gram or kg in terms of length. So here force in gram and in length. Okay, so for that we have to select one scale. So scale will be, whenever we select the scale, we have to observe the maximum dimension or maximum value. So here maximum value is 200 gram. Okay, so accordingly you can select this scale. So if here maximum is 200 and you have minimum as a 100 gram. Okay, so you can select 1 centimeter as a 25 gram. So your maximum length in the polygon, that is the maximum side of that polygon, it will be 8 centimeter. Okay. So here 100 gram force, it will become, that means F1. So F1 is 100 grams, so it becomes 4 centimeter. F2 is also 4 centimeter. F3 is 5. F4 is 8. And F5 is 5. So here we have converted force value into, force in gram into length value. Now you can start for the force polygon. So for that we have to select the reference point. So this is the origin. Okay. At the reference point, just draw reference axis X and Y. Now observe the force F1. Force F1, its direction is 35 and its length is 4 centimeter. So draw first vector having the length 4 centimeter. Okay. So this is your F1. Let us take this point O and this is the point A. So we have represented F1 in terms of length, and this angle, it must be 35 degree. At the end point of the first vector, that is the F1 vector, again construct X and Y axis. So this is just for your reference. After F1, what is the next force? It is the F2. Okay. So from this point, draw the vector parallel to this line. Okay, so here angle with respect to negative x-axis, it is 30 degree. So draw the vector, and f2 is 4 centimeter. So this is also 4 centimeter. This is your f2. This angle with respect to this negative x, this is 30 degree, and this point is point B. At this end point, again construct x and y axis. Then next vector after f2, it is the f3 at an angle 40 degree, and f3 value is 5 centimeter. So draw the vector which is parallel to f3 or at angle 40 degree. So with respect to this negative x-axis, draw this vector, and this angle, this is 40 degree. This total length B to C, this is equal to 5 centimeter, and this is your f3. Again at this point, that is end point, draw vertical and horizontal line as a reference. Next is f4 exactly downward, and length is 8 centimeter. So draw this exactly vertical line. Okay, so this is your f4. C to D vector, which is 8 centimeter. At this point, again construct vertical and horizontal line, and then draw the vector for f5, which is the 5 centimeter parallel to this line. Okay, so this is your f5 D to E. Now the closing side in the opposite order. Okay, so right now this is our order in the anti-clockwise direction. Okay, so from this point, draw this vector. So O to E, this is nothing but the resultant. Okay, so if you measure this distance by using the scale O to E, so you will get the length OE. From the length, we have to find out the magnitude. So resultant is equal to length OE into this scale. So for time being, assume we get the length OE. Suppose the length OE from the experiment or from this polygon, this is equal to 2 centimeter. So what is the resultant? Resultant will be length OE into this scale. So what is the scale? 1 centimeter is equal to 25 gram. So we have to multiply by 25 gram. So length O is 2. So resultant is 50 gram. Okay, so this is the experimental method. Okay, from the force polygon, we calculate the resultant as a 50 gram. Now we have to verify this answer from the theoretical value by using this summation fx and summation f1. So you know the procedure how to write the summation fx, summation f1. For that, we have to resolve this diagram. So we have the space diagram. Okay, so here we have the force value as 100 gram. This is 100 gram. This is 125. This is 125, and this is 200. We have these angles. Okay, so you can resolve the force like this. Find out x and y component. And then write summation fx, write summation fy, find out the resultant by using this formula, summation fx square plus summation fy square. Okay, and also you can find out the angle of the resultant. So theta is equal to tan inverse summation Fy upon summation Fx. So before that, observe this sign of summation Fx, summation Fy. Accordingly, we have to decide the quadrant of the result. Okay. So here from this diagram, we have the resultant like this. So similarly here, you will get the resultant in the fourth quadrant. Okay. Then you will get this angle theta by using this relation. So this is your resultant. So you can verify this angle and the resultant value with the experimental value, that is from the force polygon. So for the force polygon, if you want to find out the angle, then at the O point, you have already drawn this vertical line and the horizontal line. Okay, you can measure this angle. So this is the angle theta. Okay, so this is the resultant and the angle of result, and you will verify this by using this formula R and this theta. Okay. So here you can see this is the experimental setup. So this is the board which is mounted on the wall. And this is the string which is passing over this pulley. Okay, so this pulley we can change its position up and down. Okay, and we have connected the weights. So this weight, it will create the tension in this cable. So this is your F1, then this is F2, this is your F3, this is the F4, and this is F5. Okay, all these cables, their line of action, they will pass through the center point. So this is called as a point of concurrency. Okay, so on this paper, we will draw the direction of this string so that we can get the direction of force. For that, we need to use the mirror, so we can trace the direction. So you can use the mirror and you can mark 2 points by observing the mirror image. So mark the points for all the forces F1 to F5. And then mark this point of concurrency. So you have to just extend this line. Okay, so you will get the intersection. Then you have to note down the weight connected. Okay, so all the weights, they are taken in the gram only. And then remove the paper. So here you can observe these are 2 points for the direction of that line of the force F1. We have to connect this point with this center point. Okay, so connect all these points with the center point, so you can observe the space diagram. So connect this 2 point with this center. Okay, so after this, we will draw the force polygon. So this is your space diagram. Okay, so here we have connected this 2 point with the center. Okay, so you will get the force F1 direction. So similarly connect all the points. Now here you have to measure this angle. Okay, so during the experiment, I have just taken this angle as a theta1, but we have to measure this angle by using the protractor. So here I have not written theta4, okay, because theta4 or force F4, it is exactly in the downward direction. Okay, so this is your space diagram. Now you have to draw the polygon diagram. So for the force polygon, you will convert F1, F2, F3, F4, F5 into length. So this is the weight value in terms of gram. So I have taken the scale. 25 gram is equal to 1 centimeter. So you can see here F1 becomes 5, F2 is 5 centimeter, F3 4 centimeter, F4 1 centimeter, F5 4 centimeter. Now by referring the space diagram, you have to draw the polygon. So first select the reference point, draw the reference axis X, and you can draw the Y axis also. Now observe this direction. Okay, that means this theta1, and draw a vector parallel to this F1. So this is your first vector, that is the starting line of that polygon. It must be equal to 5 centimeter. Okay, so after the end point, that means from this point, again draw reference axis. We have to draw the second vector, which is parallel to this F2. So at this point, let's draw vertical and horizontal line. So here I have drawn with approximation. Okay, I have not measured the angle, just I have drawn parallel lines. But you have to measure the proper angle, this theta2. And similarly, complete the vectors for remaining forces. So once we complete the last F5 vector, okay, and this closing side. So actually, if the resultant is 0, that means this F5, this line, it must end at the starting point. Then you will get the closed polygon. The meaning of closed polygon is there is a resultant 0. But if the polygon is open, okay, then there must be some resultant value. So you can find out this resultant value from the closing side. So this is your closing side. So this is O to E. Okay, don't draw this by freehand. You have to draw this by a scale. Okay, and measure this side by using the scale. Okay. So suppose if you measure that distance O to E, and if you get that 1 centimeter, suppose length OE, that is the closing side, is 1 centimeter, then multiply this 1 centimeter by the 25 gram, that is a scale taken. Every time your scale will not be 25 gram. You have to decide that scale. Even you can take 50 gram, you can take 20 gram, 10 gram. So if you take the less value, that is a 10 gram, then the vector length, it will increase. Okay. So by observing your paper, the size of paper, you have to select this scale. So here you will get 1 centimeter into 25 gram. This is equal to 25 gram. That is the resultant value. Okay, so this is experimental procedure. We have got the value as a 25 gram from the experiment. Okay. So what is the theoretical? For the theoretical, you have to write the summation fx and summation x. So I have seen your experiment. Those students have submitted. All students have made the same mistake. So in the write-up, there is one page having the observation table. So this observation table, it is only for the theoretical procedure to find out the result. So in that table, I think first column is serial number. So here we have 1, 2, 3, 4. Then we have force F1, F2, F3, and F4. Then after that, we have their angle. So this angle is with respect to x-axis. Okay. Then we have there's fx, x component, and the y component. And here we have summation fx and summation f1. Okay. So in that write-up, I have given this space diagram for observation 1, and for on the last page there is observation 2. Okay, and we have to copy one observation as it is from the experiment. So total we have 3 observations. So in the observation 1, I have given this space diagram like this. So here we have total 5 forces: F1, F2, F3, F4, and F5. Okay, and this is the angle. In the observation table, so there is one observation table which consists 4 forces. So all the students have just calculated summation fx and summation fy only for 4 forces. Okay, actually in the system there are 5 forces. So in this observation table, in the previous year, student conducted the experiment by considering only 4 forces. They have not considered this force, and therefore this is the observation table which consists only 4 forces. You have to add the 5th force, and then you have to calculate the summation fx and summation fy. So diagram is for 5 forces, and your theoretical calculation, you are only considering the 4 forces. So it will give the wrong answer. You cannot verify the answer. Okay. So consider all the 5 forces which are shown in the diagram. Okay. Write their angle. Even if you don't draw this observation table, okay, still it is okay. We have to just resolve the forces for theoretical calculation. No need to resolve the vertical force. And then write directly summation fx and summation fy. After that, calculate the result. Calculate their angle. Find out the quadrant. Maybe first, second, third, or fourth quadrant. Show the resultant. Show this angle. And then verify this angle with the closing side of the polygon. Okay. So I have seen the submitted experiment on the classroom. Most of the students have just calculated the resultant only for 4 forces. So in the observation 1, observation 2, and observation 3, there are 5 forces. So we have to consider all 5 forces. We have to draw the polygon, and then we have to verify by the experimental procedure. Okay.